You're muted, Leighton.
There we go. I don't know. Technology. Good afternoon, Sam. How you doing, brother?
I'm doing great. Good afternoon to you too.
Happy holidays.
Yeah, Merry Christmas. Good to see you.
Yeah. It's been a minute.
It has been. I like the dogs.
Yeah, they love to be the center of attention. So
Yeah.
you got to do what you got to do. But so how's your year been?
It has been a very wild ride. A lot of stuff has happened. A lot of stuff is happening. I think the big thing that's changed is last time we were talking, I think I was telling you we were going after this big grant, and we won it. We got that big grant.
Well, let's talk about that to start.
Yeah. So this, when was it? When was it the last time that we spoke? Do you remember?
Dude, it was probably 9-10 months ago at least.
It was a while. It was almost.
Yeah. It could have actually been at the end of last year.
It might have been.
Yeah.
Well, at that time, I think I discussed that we were going after a National Science Foundation Phase 2 grant. So our work at the time, we were really interested in finding ways to get bacteria to digest oils that we produce from plastic waste. And we were making some really good progress with that. And so we pitched this idea to the National Science Foundation, and we won. We won that grant. That was a $1.2 million grant, which is crazy. It's a huge amount of money, most amount of money I've ever seen in my life. But also, it's really good validation of the science we're doing because they got a whole team of PhDs and stuff like that, and they signed off on it. They really think we're going in the right direction with this.
Fantastic. So when are you going to start with the data collection?
So we've actually already started. That's the exciting thing. So technically speaking, the grant kicked off in July. We got all of our paperwork and everything rolling. And a couple months ago, 3 months ago, basically, we really got our project rolling. We have been pyrolyzing, so, heating up super hot, a bunch of plastic, collecting oil from it. And literally right now, below my feet downstairs, we have bacteria eating a bunch of oil we got from various plastic bags and other things.
Nice. Now, once they eat it, what are they releasing?
So that was one of the big things we talked about last time is, when the bacteria eat these plastic byproducts, what are they producing? Are they making microplastics, nanoplastics? Is there toxic waste? And my answer at the time was no, from our own internal chemical testing. But we talked a lot about wanting to get third-party analysis done. We wanted some third-party tests done to show that this digested plastic material was safe. And so we did. We actually sent the material to some forensics labs. We sent it to a number of different chemical labs. They came back to us. No microplastics, no nanoplastics. It's just, all it is it's pure biological material. It's mostly cell biomass, but a lot of it is also just like organic acids. And we were able to turn all that into worm castings, and we had the worm castings analyzed likewise, just worm castings. It's a 1-to-1 match with regular earthworm manure.
That is impressive, my friend. So let's talk a little bit about organic acids. They have all kinds of different effects on plants.
Yes.
And we can talk about individual acids or the acids as organic acids as a community. So why don't you, if you know the different types, let's talk about them and the plant reaction, because this is something that I've been working on as well in trying to better understand like the muncher process, also extraction methods, because we have a similar situation where we are releasing these acids, and for the most part they're plant available. Some of them aren't. Some of them have to be digested by bacteria first, but the plant response is undisputable.
So that's the really interesting thing about this process is, first you take plastic material and you're depolymerizing it into an oil. And then the oil is actually being eaten by the bacteria, and that is then kind of being metabolized into a mixed broth of acids. We're getting things like, phenylacetic acid, but we're also getting like different kinds of polyphenol compounds. So even things like caffeic acid. Then those compounds are being fed to the earthworms. And the earthworms are further processing it into humic acid, fulvic acid, just all the kinds of different things, the tannins and stuff that you expect to see in earthworm castings. So it's really amazing because it's plastic in the front end, and then by the back end, it's worm castings, and it's earthworm castings that are utterly indistinguishable from ordinary earthworm castings, like the ones fed with like pumpkin or watermelon or whatever. We're not seeing any difference.
Really?
Yes.
Have you? I'm sure you have, but I gotta ask: have you gone down the DNA rabbit hole?
Yeah, we've done metagenomic analysis on it as well, and there are slightly different populations of bacteria, but it's really just kind of what you expect to see in worm castings. And yeah,
you're not even shifting the community that much.
Not really, no. Now I should note there is one caveat with this, which is that we're doing relatively small batches. So we're talking about maybe a dinner plate size chunk of plastic material or post-plastic material. And so I mean, it's going into a worm bin that normally processes 50 pounds of material. So it's not a lot. It's not a lot of material that we're starting with. So maybe if you were to scale that up to let's say a farm size, you might see a very different bacterial mixture. But right now, not so much.
All right, what is the plan? Is this like a high nitrogen type compost where you use 35% greens, 65% greens, and 10% of this feedstock? Is that kind of the approach that you're taking?
Yeah, we're doing a very basic worm farm style mix. So it's mostly brown in the sense of we're using spent castings and cardboard or whatever as the bedding, and then we're throwing in a bit of leafy greens and some fruit matter, and then we're topping that off with 10-20% of this material, which we call biogel.
So you really are. Then you're following what we would consider a compost standard approach,
yes,
which is fantastic. Is the goal at some point to increase that 10% to a greater value?
Absolutely. Yeah, that's the dream, right? Because we want to be able to replace a lot of the essentially the greens in this compost bin, if you will, with this plastic originated material. That's the hope, is that it could be one day be all of that. So 30% of the mass of the bin was once plastic bags or films, or we've even found now that even biomedical waste can be useful. So old syringes and things like that, you vaporize them and then you recollect those vapors. They're sanitary at that point, and the bacteria eat it.
Interesting. So you're actually getting into distilling.
Yes, it's distillation of plastics. It is very, very cool. And what's most amazing about it is that it's a relatively simple process to feed this to the bacteria afterwards. So we're now engaging in trying to accelerate the evolution of this bacteria. We're doing kind of selective breeding like you would with any animal to try and get them further and further along. Not genetic engineering, but just breed them, put them into conditions, make see more of what they are able to do, and just keep pushing it.
Yeah, that's called horizontal gene transfer.
Exactly. Yeah.
Very cool. And so let's talk about the conversion through pyrolysis.
Yeah.
Pyrolysis. So low oxygen, high heat, pressure.
Yep. Actually, no pressure on this one. Yeah, we're doing full low pressure system. We got a nice mix of catalysts, but it's not even all that hot. It's relatively low temp for pyrolysis. As long as we control the feedstock somewhat. As long as we do some sorting of the plastics we get.
Okay, so is there a blend that you're using in that technique, like a plastic bag to food storage box? What's that look like?
We're still experimenting with that. We really don't know the optimal ratios right now of how wet does it have to be, or what kinds of bags mixed with what makes the best output. But we have been distilling the oils that come out the other end to try and isolate different densities of oil, and we've been finding that those different densities do have an impact on the digestion. So we're learning a lot as we go, but it's looking really promising so far.
So essentially, you're doing like the old oil water separation. The heavier ones sink to the bottom, the lighter ones float to the surface.
Exactly right. Yeah.
And then you make notation and then move them into further processing.
Yep.
Is there a bacterial blend that you use on the different viscosities?
Right now, we're using the same kind for everything, but we're trying to vary it. We're trying to test it, and also, like I said, selective breeding I think is going to be a big part of that. You know, the more we find that these bacteria adapt very quickly, right? So the faster we exposed one generation after the next to this material, the faster the bacteria will adapt to it, and eventually we'll produce them that are more specialized for specific mixtures.
Got you. Cautionary tale. Don't ever try to just reproduce. Let them evolve. I had a very interesting relationship with a gentleman who got so focused on the money that they did not want to improve the generations of their specific bacteria, or they were 5 species. And now it's gotten to the point where the people that originally supported this product are like no longer using it because of the genetic drift. So it drifted away. It's like inbreeding. Eventually,
you can't have that with something that is this sensitive. Like it really has to be able to digest those oils. Otherwise, it's of no use. So we got to make sure that it's. But that's the benefit of our system is we're keeping mother cultures every time we run different plastic through. And the plastic may change over time too, so it has to continue to evolve. Otherwise, it will lose its effectiveness.
You ever heard of biosymbiosis?
Yeah.
Have you thought about starting to play with that?
A little bit. So we've actually thought about doing a couple different kinds of symbiotic systems, but right now, like I said, we're kind of still working through like what are the different outputs from the different plastics. So we don't want to get too ahead of ourselves with how we're actually consuming the oils just yet. But it is something we thought about a few different ways to do that.
Yeah, this is I forgot how deep we went the last time we talked.
Yeah, we did. It's pretty wild stuff. I mean, there aren't a lot of, as far as I'm aware, no one else is doing this specific thing, but there's just not a lot of people working in the space of trying to get these plastic materials digested, surprisingly, as big of an issue as it is.
Have you played with the oils as far as combustibility?
Yeah, I have. So I mean, that was the big promise of pyrolysis originally. I'm sure you remember, is like turn the plastic back into fuel. Mm-hmm. And so our concern has been, well, how volatile is it? Because we don't want a fire hazard, and also we don't want to be like losing this classic oil to evaporation. But also, is there any possibility of like capturing maybe the most volatile fraction and using that as a fuel rather than using it as a fertilizer precursor? But ultimately, the energetics just don't work out very well. But the other big issue is that the oils are relatively miscible. So they're not as flammable as you would think because they kind of mix into each other unless you really go through the effort to distill them, at which point the energy just doesn't work out.
Yeah, thermodynamics doesn't work.
But the gaseous output, this is what's crazy. The gaseous output, so like the syngas portion, that really does pay for itself to capture that. You capture that gas and you burn that really does pay for a lot of the energy. So, but that's all like the methane fraction. It's not any of the 80 to 90% of it is just the oils. So, but we want to avoid burning it as much as possible because if we can turn it back into soil, its value, I think, is just so much higher.
Agreed. We're applying for a grant ourselves. We're co-applying with a national lab on what's called phyto mining. There's a more intense word, but it's basically using biology and plants in conjunction to pull minerals out of the soil that we can then turn around and through other processes like yours, where you take that plant and then you get the metal or the desired mineral to precipitate out into a solid form, and then use that as a way of more gently extracting, we're probably going to end up starting in mine sites because we know there's an abundance of the spent material that we're looking for that was in a impurity form that wasn't enough for them to go through that process.
Yeah, the tailings, I think they call those
extractions.
Yeah.
So, it's a beautiful thing because you're bioremediating what you're extracting, and we're also going to be targeting like specifically the plants that live in that harsh environment.
Yeah.
Cultivating them, and then of course supplying all kinds of biological inputs, everything from inoculants to biostimulants, and really trying to charge that system. And it's like it's a lot along the same lines as to what you're doing. And
Yes.
and this is like the DOE threw out like huge dollar amount for people to look into this. And
Yes.
it's almost staggering how much that they're willing to spend on. And again, this is like friggin' exploration. Like there's not a lot of people doing it.
No.
And there's so much to learn.
There is, especially with like, the mining metals, the offtake, the tailings, they are a huge problem because they do cause a lot of toxicity to the soil and eventually to people. So being able to do something about that is huge. That's one of the reasons we studied earthworms to begin with, is because they are exceptionally good at metal sequestration. That's one of the most profound, useful abilities of them, is to pull minerals out of the soil, sequester it into their biomass, and by doing so, protect plants.
So it sounds like you've already looked into that. So what happens to the worms when they consume a bunch of aluminum or lead or nickel or whatever? Do they change color? I mean,
well, I mean, so that's the problem, right? Like, so there are a lot of studies that have been done on this about using earthworms to sequester heavy metals or other materials. And one of the things that they found repeatedly is they found that some of these are pulling in like cobalt, nickel, iron, whatever out of the soil in large quantities. But if the worm population isn't large enough, they will overwhelm themselves and die. If the worm population is large enough, though, what will happen is they will instead absorb those materials. Those materials will end up inside of their biomass, and then you can essentially trommel the worms out of the soil and use it as an engine to pump those minerals out of the ground. I think the Brazilian government was actually looking into this substantially not long ago for like sewage treatment, right? They had all these heavy metals ending up in the sewage. So they figured out isopods, earthworms. You use these guys to basically eat that material, and they will pull it into their biomass, and then you basically incinerate them, and now you can recover those metals or materials, or at least isolate them. Yeah.
Poor little guys.
Yeah. But that's kind of, they have this sort of, it's really unusual. Like, you don't see a lot of organisms do this, but it's like a self-sacrifice play. It's kind of a kamikaze like maneuver that they do, because the earthworm is sort of making a bet, right? Like, physiologically, if the earthworm takes one for the team and absorbs this cobalt from the soil or lead or what have you, the earthworm will suffer for it physiologically to some degree, but the plant will be much healthier and produce more leaf matter and leaf litter, which will then feed more earthworms, including its offspring. So by taking one for the team, it can then have 6 or 7 or 10 kids, and those kids, those offspring, can then have a much healthier environment. And as long as the population of earthworms is stable or increasing, the heavy metal contact to the plants will be near zero, and the heavy metal contact to the earthworms will be declining over time. So as long as they're stable in the system, they keep that, which is one of the bad things about earthworms dying, because if we kill earthworms in soil today, it's kind of a Pandora's box. You end up killing these organisms that were acting as a biological like bag of holding for these horrible metals. They all die off. Suddenly the level of heavy metals spikes in the soil, and you're like, where did this come from? Well, it's because the earthworms were holding it generation to generation. They were absorbing it, and now they're gone.
Worse yet, it becomes bioavailable, so more toxic.
Yes, exactly. So you have to keep those organisms in rotation, or you have to trommel them out of the soil. Otherwise, whatever lead or cobalt you added to the soil originally is it's gonna be released.
So how do you figure out which ones are, I don't want to use the word most toxic. I want to use the word,
Or carrying it, yeah.
Yeah, how you use a metal detector?
You can't, and it's only gonna be like a gram per worm at most. It's gonna be small amounts. So what you do is you literally you take the worms out of the soil, and it's kind of like decanting. You take them out of the soil, and then maybe you let them produce eggs, and then you put the eggs back into the soil to pull more out, and then all the adults you pulled out, you burn them.
Interesting.
And now you have kind of like a heavy metal rich fly ash. And that ash you can then use, if you get enough of it, you can actually refine the metals back out of it.
Yep.
But if you don't, you have like a carbon black material you could use for roads or other things.
God, this leads down so many paths.
It does. It's a really wild idea, and I don't know why it hasn't been used that much.
And I wonder if like there's a point where perhaps you could actually use magnets or magnetism itself as a way to encourage them to, raise their hand, so to say, and say, "Hey, I'm done. I'm drunk. Take me home."
It's possible. I mean, there's a lot of ways. They're very unique organisms because they don't respond to a lot of stimuli, right? They have no eyes, so they don't really see much. They can't really detect light. They can only detect like heat, warmth, and wetness.
And vibration.
Vibration, but they may respond to electromagnetism. I don't think that's been studied. That's kind of a mystery. What do worms do if you slightly electrify the soil? I think you've probably read about this. People were doing
they come to the surface, kind of similar to like when you use vibration.
Yeah, I bet they would. I just didn't know. Voltaic farming is what they call that, I think.
Yeah, my uncle, or he's kind of a adopted uncle, was an Indian or a Native American in Maine, and he taught me how to make a stick with I'd cut little notches in it.
Yes.
Pound it in the ground and then run another stick up and down it at 5 o'clock in the morning to collect the worms so that he and I could go fishing when he arrived at 6:30.
You know what they call that?
No, I don't know what they call that.
It's called worm grunting.
Worm grunting.
Grunting. Yeah, that's the term for it.
Interesting.
It's an ancient art. People have been worm grunting for thousands of years, I think.
Yeah. There's so much we've lost about these really deep relationships and connections to Earth. We have another issue with a specific type of worm. Some people call them Georgia jumpers, or the ones that just shred the organic matter layer to the point where the fungi can't support. And I wonder if they would have some benefit in this process, because they're so evasive that they're really like causing forests to collapse, and it's sad. There was a space in Connecticut that a buddy of mine who's a truffle hunter and I went in to hunt truffles, because it's it's very very undisturbed area. It's got a lot of watershed. There's natural artesian wells, water bubbling up, and there was a tremendous amount of like advanced life, like deer, fox, coyotes, and everything else. So it was a very rich environment, and we went in there hunting, and I was like, "What is going on here, Efren? Look at the soil; it's all like little Rice Krispies. What is happening?" And he's like, "Oh, I know what this is." And then he started explaining to me about those invasive worms. And
the jumping worms.
Yeah, we're not going to find any truffles in here because the fungi can't support himself. So obviously it's not going to produce the flower, so to say, of the specific species of fungi that we're trying to hunt down. And then I started talking about this, and people thought I was crazy. I got, kind of humiliated in a number of ways from different people, saying this is bullshit. And then finally, a permaculture friend of mine called me and said they devastated my garden. And she's like, "I didn't believe you when you were talking about this stuff, but now I have proof." And she asked me, "What can I do?" And I said, you really have two choices. Either build raised beds so that they can't get in there, or, the electroculture, put a car battery and a couple of rebars and put some freaking metal,
Shock
wires.
those worms.
Yeah, shock the shit out of them. But I go, that's only a fix. That's not a permanent solution. And we did talk about using the stick and vibrating a little bit, but sadly, since I've moved to California, I've lost touch with her, so I don't know what she ended up doing. But I wonder if there's a way to harvest them and turn something that's being invasive into something that's being beneficial through a process like what you're doing.
Definitely. I think there are a lot of reasons why that could work, but well, I mean, there are a lot of examples I think we've seen recently in ecology of like invasive species being twisted into an opportunity. Like they find some way to like, okay, well, maybe we can actually do something useful with this. Maybe twisted is not the right word. Like here in Florida, right? We have these lionfish. Lionfish are huge.
Yeah, I've heard about them.
Yeah, they're to the point where there was a guy, a scuba diver, who was going around with a Glock shooting lionfish. Like, but they're a huge problem, right? Because they're venomous. None of our predators can eat them. They just chow through a lot of the resources. But they figured out that actually lionfish are delicious. Yes. And so, people are now they'll pay you to hunt the lionfish to bring them back to restaurants to cook them. Plecos, Plecostomus, that was a similar problem. Those guys were really horrific. Turns out they make great dog food. they're turning plecos into dog food. So there's a lot of these like different things that can be done with invasive organisms. I think you're absolutely right. There's got to be a way to take the jumping worms and do something with them.
Are they still for sale down there in the South? Because that's where they originated. Yeah. They were Asian jumping worms. Asian, what do they call it?
Malaysian jumping worms originally, yeah.
Yeah.
Yes.
They were selling them at debate shops.
Yeah, well, that's the problem. Is this is where they're doubly problematic. One, they are extremely easy to raise and very difficult to tell the difference between them and regular worms. So tons of the worm farmers down here started getting them mixed in with their worm farms. But the other problem is they actually suck as bait. They're not even useful because they're rather small and you can't put them in a freezer very well. So if you stick them on a hook, they break most of the time. So they're not good. They're not good for fishing, which is triply, horrible because it means not only are they filling all the worm farms up and they're out competing the good compost worms, but they're also not even useful for compost or for bait, but there's got to be something you can do with them. I mean, I imagine maybe it could be just sequestering heavy metals out of bad soil and burning them to make ash rather than, maybe in death they can serve as something useful.
I mean, they do an amazing job of just tearing through the organic matter. To the point where they're making Rice Krispies. And again, they're not ideal for composting per se, but they are probably pretty good, especially if you had some kind of resource of contaminated organic matter.
Yes.
They'll do a hell of a good job.
They'd probably be fantastic at that. That is a very interesting concept. And I would be interested in pursuing that more if I weren't so busy doing this.
All right. You need more help because you need to be pursuing this stuff.
Yeah, I do. I mean, I got that's the thing. I got a team of 9 guys here, and we are like bumper to bumper doing stuff constantly. We just got an order for 5,000 gallons of earthworm tea up to some major farms, and we're going to be doing 40,000 gallons before the end of the season. I think last time we spoke, we were just gearing up for our big production run. We ended up doing 25,000 gallons in sales to farms. And I think in the end, it ended up more than that. I think it was closer to 30 and change because we had more farmers at the end of the season come in. This year we're doing at least 40,000 and we've already got our first 5,000 going out. I mean, it is crazy to see. I'm skeptical to make this claim, but I'm going to go ahead and make it with an asterisk because I've never seen anyone make more. I think we are producing more earthworm casting tea in this facility than than anyone has ever made before in any quantity, which is pretty crazy.
That is cool. So right now, are the farmers in Florida and the surrounding area applying product, or are you kind of in a standstill?
It's surprisingly, it's not that many farmers in Florida who are using it. We're selling mostly to Midwest farmers. So we had some really crazy results from last season. We had a lot of people doing corn and soy. We saw people getting their corn bricks level. Are you familiar with the bricks?
Yeah.
Score?
Oh yeah.
Yeah, I bet you are. I don't know why I asked. The brick score they're seeing in these corn is 7 or 8 is what they're starting with. By the end of the season, 28 in some of these farms.
Damn.
Which is crazy for corn.
What kind of application rates? You know,
this is 32 ounces an acre on this corn farm.
So it's fractional.
It's very, very, very small. So
are they in pivots?
I think so, yeah. Well, actually, this might have been a foliar application. I have to double check what this one was specifically, the 7 to 28 version. But regularly, even in other farms, we're seeing 10 to 21, 10 to 23. Like 7 to 28 was the most dramatic one, but we've seen a lot in the middle range on various systems: in-furrow, foliar, pivots, booms, and this is corn from Maryland all the way to Missouri, and that's crazy. But with soy, we saw bushel increases beyond just the nutrient benefit. We saw a bushel increase of 38 to like 52,
Wow.
Which is a huge, huge increase from applying this stuff. Better drought resistance. So a lot of these different things from applying the worm castings. And so, yeah, we're getting a huge amount of interest from a lot of these farmers. That is just, for them, it's fantastic. They're saving money while being organic. And every time they learn that it's cheaper than the synthetic fertilizer, it's huge for them. They smile from ear to ear practically.
Well, that's the hardest thing in the world with these guys, is to convince them that what they have in their soil is everything they need already. They just need the biological approach. And, that's always been a challenge. And the farmer that I did convert, was the only reason he did was because of the war in Ukraine, and the price of fertilizer went through the roof. And he took the jump, but he called me like pretty much every day or every other day, just going, "Are you sure this is going to work?"
Yeah, he's nervous. He's never done it before. You got these guys. They've been farming the same way for 30 years. And, they got the scientists from the big company come by, and they give you the profile, and they say, "Yeah, we got 40 other farms doing this. All your neighbors are doing it." That's easy, But when it's like, "Hey, I want you to try this thing that is..." It's not what all the businesses are telling you. It's not what all the sales guys are telling you. And hey, it's even cheaper. Then it's like, okay, wait a minute. What's the catch? Where's the problem with this?
Yeah. It's too good to be true.
Yeah.
How did you get your first several farmers to come aboard?
So we gave free samples. We had a distributor we were working with, and we gave them some samples, and they sent it to the farm. The farmers were like, they didn't tell the farmers what it was. They were just like, "Here, try this on some fields." The farmers were like, "Okay." And they're like, "Wow, this is amazing. What is this?" And they tried, explaining it. And they were like, "Give us more of that worm oil shit. Come on." and they started telling all their friends about it. So all these farmers started asking for the product, before we never even spoke to them. They just saw what it did on some of these demonstration, plots. And before we knew it, we were up to our ears in orders, and now we're doing, like I said, we're doing double what we did last year, and last year was huge.
Yeah, you didn't even have that many employees when we last talked. I don't think you even had 5.
Yeah, it was 4 of us. Yeah,
I thought there was about 4. Yeah.
Now it's 9.
That's congratulations, man. It's so nice to hear these successful stories, especially when you're doing such a wonderful thing for humanity as a whole.
Yes, I mean, it's
spinning gold out of lead.
It's not quite that amazing, but it's really gratifying, because I mean, we had two fronts to this thing. One, was our hypothesis even correct? Can you even turn plastic into worm castings? And if you can, is it even agriculturally beneficial? And then the other side of it is, worm castings as a fertilizer. Can we convince farmers to do this industrially, with a liquid, especially because we're just a group of guys. Like, we're not you know, we're not the A team of geniuses and like massively funded people that Bayer or whoever else has in their back pocket. You know, we're just a couple of guys. So it was a big question mark, but it's been really gratifying to see it come along. There's still a long way for this to go before we really, I think, are making a big difference, but it's starting to happen.
Yeah, I think the one thing that you're not really giving yourself enough credit for is that the fact that you guys are not siloed into a little pocket and you have to just do this. You're allowed to speak out and talk about and brainstorm on some of these aspects. So you're always going to be ahead of Bayer. You're always going to be ahead of Monsanto or any other giant corporation because you're not following that corporate mentality of no, you can't let what we're doing out. So you have to put each person in a specific category and not let them talk to the other members. So you're ahead of the curve.
Yeah. I think it makes it a lot easier, but I'll tell you what too, it's been nice is we still don't have any. I think last time I talked, I was like, maybe I'll bring in investors or something. We just decided not to, you know, we didn't bring we didn't bring in any, what do you call private equity? We didn't bring any of those guys in. We've just continued to bootstrap and fund the whole thing from sales and from grants. And that has meant a level of freedom, which I think is missing in a lot of people in our space.
Oh God, yeah. There's nothing worse than venture or an infusion of cash because now it's all about the ROI and not about the product and getting it to the next level. That was what happened to that other company I talked to you earlier about, where they had so much inbreeding that the product just hardly works at all anymore. So, and that was all purely driven by ROI, money, go.
Grow as fast as you can.
Which
is like ironic because our whole thing, right, is we're trying to grow plants sustainably, right? We want them to grow in a way that they're not being given like steroids, basically. We want them to grow sustainably. We want them to grow in a way where the soil is healthy. Why wouldn't you do the same thing with your business?
Right. Grow it organically.
It's an organism in the same way that a plant is or an animal is,
See, I think a lot of the difference between you and a lot of other people is that you're not highly focused on the money. Because as soon as you get money drunk, forget it. Now you've lost your focus on what is really important. And it should never be about the money because at the end of the day, I mean, look what happens to all the people that make a ton of money. They blow themselves up or go crazy.
Become evil.
Yeah, literally, It's
the root of all evil.
Totally. And I get people look at me cross-eyed when I say, no, I'm not about the money. I'm about the work. And it's like, well, everybody's about the money. I'm like, well, I'm sorry, but I'm not. So maybe I'm fucked up. Right?
Maybe you're messed up. Yeah. Maybe you got the problem. Well, I mean, it does make me remember that scene in what's it called? It's the movie with Garth and Mike Myers. They get the product sponsorship,
Well, it wasn't Weekend with Bernie, was it? Or
no, it's that movie called. I'll remember it like 5 minutes from now, and I'll feel
all right.
But what do you use the money for at the end of the day? What is it going to be used for, right? I mean, for most people, they have other things they want to do in life. Well, for us, the big thing is we want to destroy plastics. Yeah, we want to live. We want to be able to have
of course.
A nice standard of living. But we're also trying to achieve something. We're trying to better the world. We're trying to better the conditions in which humanity is forced to live. So Wayne's World. Yes.
Wayne's World. Yeah.
Thank you, Red Setter. I couldn't remember it for whatever reason. Why can't I remember? Yes, in Wayne's World, there's like a scene where he's like, no way, man. This conversation is giving me such a headache. Here, take 2 of these. That's such a good movie. But
I think the biggest problem is when people do get money, it becomes about possession.
Yeah.
Right. And then possession gets as addictive as any other possible thing you can imagine, because it's like, oh, well, now that I have a Rolex, well, maybe I want another one. Or now that I have a nice car, maybe I want an SUV. And I learned that the hard way, in my own marriage. It was like, by the time I ended up getting divorced, I looked around at all the shit I had. And it was like, I never enjoyed any of this stuff because I was too busy paying for it. I got addicted.
Yeah. What is all this stuff for?
Yeah. What is all this stuff for, really? And, it's shame on me for realizing that after the fact and not, while I had the opportunity to make a difference in my future. But at the same regard, I wouldn't be here in front of you today if none of that had happened. So,
yeah.
It's funny how life works, but you gotta try to, I guess, never look back or never regret what you did, even though what you were doing. Like, I was putting on NPK on my grass. I had a nice lawn. I kept it watered. I didn't know any better. I bought into the program, right? And so, anyway, we won't dwell too much on that, but let's go back into more of the science behind the work. So we talked about paralysis.
Pyrolysis. It's a tongue twister. It's a tough word.
Pyrolysis.
Yeah.
Let's talk about distillation or evaporation on what else that you're working on.
Yeah. Well, like I said, we've been working a lot on trying to take different sources of plastic waste and turn those different kinds of plastics into worm castings. And it is a very groundbreaking thing, but as a consequence, there are so many unknowns. There are so many questions that are coming up. Like, what are the best catalysts to use for these kinds of plastics to drive the specific kind of chemistries we want to get to maximum digestion by bacteria on the other end? The more moving parts you include in this, exponentially more complicated all these things become. So we're trying to take it one step at a time. The distillation side of it, where we're taking our outputs and we're trying to get the oils out of them in specific fractions so we can test, different bacteria on those different fractions. It's going to take us a little while to go through all those permutations, let alone once we start selectively breeding them, then each of them is going to require more and more permutations of the different strains to be able to produce the result that we want to get. So it's the work is mushrooming. It's so reference fungi. It's kind of expanding faster than we expected in terms of what needs to be done. But it is really exciting though. Like I mentioned earlier, we had those third-party labs analyze our castings at the end result to look for any oils or any other materials, and they found none. And so we want to keep that result. This is where you get a little greedy because you have something that works. And you're like, okay, I've got a pathway that works. I don't want to change any of the things because I don't want to have to start over at square one. At the same time, you need to optimize. So we need to change the bacteria somewhat. We need to selectively breed it to see if we can get to eat faster. Because eating the plastic faster is always better, but we don't want to do that in such a way that it then compromises the actual castings on the other side. So it's becoming a lot to track. One of the reasons why we got to have so many guys too. You got to keep track of all these variables. Something I'm really fascinated by is the application of this not just for disposal of like consumer plastics. And there's something I do want to talk about that in a minute, but also, like I said, for the disposal of specialty things like syringes and some of the plastics that are like a biohazard. So right now they're not even being able to throw those away properly. There's a whole logistics train to deal with soiled plastic and plastic material that is unsuitable for normal landfilling or even recycling. Well, this process, we can deal with that through heating and distillation and through pyrolysis.
So let's talk more about the consumables then, if that's a topic that you'd really like to dive.
I did want to talk about. So this is something I want to kind of excite you with a little bit, right? Like, you're familiar with all these programs people are doing to make compost where, it's like a subscription. People put their organic waste in a bin and the truck comes by and picks it up. And then a couple weeks later, you get compost back. Yep. So there's a lot of those programs. They have them all throughout the Northeast and throughout like California and different places. Well, we're working with one of those guys, a company called O-Town Compost here in Orlando. And we're trying to get to the point where they're going house to house, not only collecting the organic waste for people to make their own compost, but also their plastic waste. So the same subscribers with the same subscription, they get their plastic picked up as well.
Nice.
And then they can get worm castings or compost back for the subscription fee to take their plastic. So you can have homeowners and residential people rebuilding their own soil and lawn with their plastic waste.
That's gorgeous.
Isn't that a really interesting idea?
That is gorgeous. I think that that's an amazing concept. And, you know, by default, what they don't even understand yet is that as you rebuild the soil, you rebuild the entire ecology.
That's right.
Before you know it, you've got frogs, salamanders, birds, insects,
Snails, isopods, worms.
The whole thing, the whole damn thing comes back pretty quickly.
And it comes back without you having to have mined those fertilizer components elsewhere. It comes from your trash, from your plastic trash. Trash that you didn't even think of as calories or nutrients can now become calories, can now become soil substrate. So you don't even have to like all these people are, you know, you're buying compost from other places. In a way, that's still bad because, right, like if you're buying compost from somebody or black cow from somebody, what you're really buying is processed plant matter from somebody else's plot. So you're really just moving the calories from their field to your field, right? But for the first time now, I mean, other than the Haber-Bosch process, we can now move calories from the landfill, from plastic, from a place no one expected, where calories didn't even exist before.
You know, I wonder if in the future, once you've really honed in on the process and the ability to be able to build a machine that's small enough, easy to transport, that you couldn't set up that at every collection site. See, that's the other thing that's driven me nuts since I moved to California, was those big green bins. Yeah. And I'm like, what's up with the big green bins? And they're like, oh, we all take all of our yard waste and our tree trimmings and our grass clippings and we fill it in there. And then you chase that down the rabbit hole and you end up at, you know, this truck coming to pick it up, smashes it, drives it to a place where it gets ground up. And I mean, all of the energy that went into that, and then truck it back. Yeah. Right. And it's not even the right stuff anymore.
No.
Because if you just took every bit of your green waste from your site and reapplied it back on your site, now you are living as nature does, not as an irresponsible human that's putting incredible amounts of energy into something that is not necessary.
Yeah, you have a local cycle, and that's the ultimate dream of this process. As we get it miniaturized enough, it becomes like a compost bin, but for plastic. It becomes like a system you can put in your own backyard for the homeowner, or for the landfill. We bring a cargo crate, or a couple cargo crates, set up a little temporary facility on a pavilion, start mining down the landfill.
Yep.
Pulling the plastic out of it. Yeah, you're still shipping the material ultimately back to homes, but that's still better than just, shipping the compost from halfway across the country.
Right. And I mean, just out here, even in the compost yard where I work, where what comes in is so carefully scrutinized, it's not funny. And if you're a bad actor and you try to sneak some shit in, they'll flag you, man. They'll blacklist you in a heartbeat. And even with all of that, there's guys running around with the pickers, picking stuff up that's either blown in or it was too small to see, or, perhaps it was some guy's, plastic water bottle that ended up in the green waste and, buried in the middle and you couldn't see it. So those types of problems, like all the shit that they pick, which is barrels. I mean, there's a lot of it. We could convert into the same thing that you're talking about, and we have like commercial vermicompost being made. Think about how cool that could be, because that was the other thing, was that the largest compost maker in California, we almost had a pilot program with them to create worm castings to better up their compost, because their compost is garbage and everybody knows it.
Yeah.
But the only reason they sell it is it's so cheap, right? It's like, freaking, oh God, $20 for a yard. And you're doing them a favor, because like literally if they don't keep up with moving the stuff out, they get fined because they have too much material on their site. The oversight out here is stupid. It's just ridiculously stupid. But anyway, that's another type of situation that if you ever get to the point where you're ready to put a pilot out, and a piece of equipment that's manageable and doesn't cost a fortune, please keep me in mind, because I'm planning. I've already set my roots at Peach Hill Soil. I love the guys up there. Robert's amazing. I mean, he gave me like a 2 acres. Said, go at it. But, and so I've been, consulting him on better soil mixes and blends and how to navigate some of these larger scale projects like, the Palisade Fires and Santa Monica Garden Club, some things where you need to have a little bit more of just try this soil, right? Now it's got to be a little bit more blended or engineered. And anyway, so he's been really open to, suggestions and ideas. Like one of the things I told him, like, all right, dude, you got this worm facility going over here, but why aren't you breeding worms? You need to continue making more worms, because the birds come in and get them. Some of them disappear into the soil, especially when after you get, these heavy rains, everything is so hydrophobic that it just goes right under the pile and turns it into an anaerobic environment. And then the worms are out of there, right? They're like, no, I'm not hanging out here.
Yeah.
And so he started a worm breeding program. But
that's fantastic.
So we have like a perfect place to, when you're ready to do a pilot with you. That would be fantastic, because then we can get rid of all the plastic that we dump into dumpsters and haul to the landfill.
Yes. And that's the real power of this, is it's the elimination of toxic materials, ultimately. Yes, it makes fertilizer in the back end, and that's good. That's nice. That makes money. That pays for the process. But and I saw in one of the comments someone was putting out, like, green waste is really, really foul. And we've got to do something about some of this waste. And worms are the perfect vehicle to do it. Worms they've adapted to do this over millions of years. This is like their exact niche, is to do this. With a little bit of a bacterial nudge, with some extra processing like pyrolysis, we can tee them up to destroy so much. I mean, I say destroy. It isn't literally destroying the waste, but it is, it is converting it into a safe form, into a useful form. And that's got to happen across the country. It's got to happen here in Florida. Yeah, we're doing it here in Florida, but it's got to happen in California. It's got to happen everywhere.
Yeah, I agree 100%. And, this is where that whole, like, it would be great to get an investor in, because then you could just jump into it. But at the same regard, I think you're doing the right thing. Absolutely organic growth, manage the control of the business, have an R&D section. Yes. And I know it's kind of frustrating that you're like, well, I got it perfected, but you always want to iterate or innovate. You look at any really successful business, it was always about, improving the process, the technique, the energy and going in, the energy coming out. So, just from an old man standpoint, I have to say that shit.
I will say this on the investor side. Yes, it would be nice to get that, because that would help us grow really fast. But also you got to remember, like, growing fast isn't always the best thing, because like we said earlier, like we were talking about, like you sell out, you get obsessed with the money, all these other things. This problem took decades to produce the plastic crisis.
Yep.
It will take decades, maybe centuries, to wind it down and to solve it. So yeah, I would love to be making like 200%, 500%, 1,000% growth every year, like charging straight into this problem headlong. But I don't want to, I don't want to create another problem because we develop an industry so quickly just to solve the other problem. It's kind of,
Yeah,
pushing on the rope at that point.
yeah, pushing the old string, right?
Yeah.
Nothing good comes from that.
No, but I saw another question that was really relevant. So I think it's Farmer Cheryl asks this. She says, in community composting, how can you convince participants from adding plastics? With Sam's method, would the compost we produce be screened and the screening pyrolyzed to produce the oil to feed worms? So I think this is a question really about like contamination, right? I guess she's asking like what happens if a person adds plastic into their food waste. Do we need to screen it and then pyrolyze it? And, what does that like method look like? I think does that sound right?
Yeah, no, that's your approach is correct, and I think that go ahead and answer it, and I'll throw in some input as well.
Okay, so the way we've been doing this, firstly, is we have been doing what we call depackaging, which is where you use a machine.
Uh-oh. Sam?
I think I froze.
Yeah, you froze. Start over.
Okay. Sorry, what I was saying is we've been depackaging a lot of the waste plastic we get. So you get the plastic, you basically run it through like what looks like a big spiral screw, and it cuts the plastic open, and it squeezes it to get like water and yogurt or meat or whatever it is out of there. But then the rest of it just goes straight into the pyrolyzer. So we don't actually screen it at that point. We just pyrolyze it, after it's been kind of shredded. And the great thing about that, the pyrolysis, is it doesn't really care if there's green waste involved. Because what happens to the green waste when it gets pyrolyzed is it just gets heated up really hot. You end up with biochar, basically. And biochar is actually quite useful. So we get a mixture of biochar in the reactor vessel, and then oil comes out the other end like a still. And then the oil goes to the bacteria, and it's already separated, so they go ahead and eat that. And then the biochar you're left with in the vessel, well, you can mix that in with your soil, your compost at the other end. And there you have it. You do an integrated solution.
Do you sell castings, or you just make the teas?
So we actually sell castings right now. Now, I should point out, this is very critical. We are not currently using any of our plastic castings for commercial purposes yet. That is still entirely in research. While we have had third parties analyze that and verify that, we still want to go through a few more rounds of testing and verification before we release that to the public. We're also still looking for guidance from EPA and from OMRI on like what the hell does this count as? If you are managing to get a worm to eat biomass that was once plastic, does that count as organic or not? It's kind of a philosophical question. So we're still waiting for guidance on that before we really move forward with labeling it. But yes, we are currently selling the castings we make normally.
I didn't even think about that paradigm.
That's a tough one, isn't it?
So in aquaponics, we were told that because we're not in soil, you can't be considered organic.
But this is in soil. So
right. But what I'm telling you is like a paradigms. These
that
you run into that because regulation and regulatory capture are such a big thing in this country to prevent competition against the big guys, right? That you run into these scenarios. And then the other hot topic in aquaponics is that is a specific type of E. coli, which is actually beneficial to humans.
Oh, really?
But it tests hot because of the presence of E. coli. And it's like nematodes, right? There are only a few bad nematodes, and there's tremendous amount. It's to be discovered yet of beneficial ones. But they only say, oh well, we have the potato root knot nematode, kill everything, right? The nematode kills everything.
It's not all of them. There's so many species. That is really interesting. I didn't know there was a beneficial E. coli.
Oh God, there's many of them. I think there's only one negative one, but for whatever reason, they decided to target that family or community or species. No, it wouldn't be species. It's group, family.
That genus,
genus as an indicator of pathogenic potential, right? And again, ignoring all of the other members of that genus, and just saying, okay, if we see an E. coli, which is really easy to plate. And that's another one of my bitches, dude, is that these plating companies, these companies you send in your pathogens, I sent out identical samples, 4 different labs, and multiple samples of each, 3 samples of each for each one of those 4 labs, 12 total samples. It costs a friggin' small fortune.
Yeah, it's crazy what
we
have to use those kinds of services all the time in our business.
Yeah,
and it's
dude, we then also sent out that same sample for DNA.
Yep, metagenomics is expensive.
Yeah, well, I got a good one for you. I'll hook you up in a minute.
I might know these guys because we found one as well. And are they in the East Coast?
Nope, Biomakers, West Coast.
Oh, okay, different guys. Yeah, I was gonna say Rise Bio. They're very, very good service. If you ever need someone else for like a control group, Rise Bio is great.
And there's another kid we're working with, but he's not quite there yet. But he's super inexpensive as well. But anyway, back to the story. So anyway, I think there were 9 out of the 12 came back hot, and when we looked at the DNA, 0. And so the thought is that these testing labs are, how do I say, increasing their client by sending back hot tests, whether it's on purpose or whether it's poor SOPs, cross-contamination. But let's face it, you're going to spend more money if you get a hot test. Now you're going to scramble around and try to figure out what you did wrong, when in reality, you didn't do anything wrong. The plating process is not perfect.
Well, it's because they look for colony shape rather than looking at the DNA itself. But this is where I'll be devil's advocate for them a little bit, because the one thing that it must be said is, and this is a strategy that's been used in the engineering world forever. You look for fail safe rather than fail deadly, right? Like with these kinds of bacteria, it's really easy to identify E. coli, especially before we had metagenomics, from plating. And if you see it at all, it's better to just say, all right, let's be safe, let's get rid of it, rather than be like, okay, well, hold on a minute, what are we actually dealing with here? Because back in the day, we didn't really know which E. coli was doing what or how, and it was very hard to tell. So now with modern metagenomics, that's a lot harder of a position to defend. But I do see where they're coming from. Like, okay, if you show any of it, it's better to just say, let's have a fail safe and just scram rather than try and figure it out further. But yeah,
well, I'll agree to disagree with you. My point is that they need to upgrade.
They do need to upgrade. I agree with you on that. I'm just saying I think that's where that attitude came from, but they haven't evolved.
Yeah, and I can see that. Like when we had no technology and what we did have, as primitive as it was, I can understand saying that, okay, the potential's here, get rid of it. Yeah. But with the modern technology that we have, it's like soil science.
Yep.
Soil science industry is the same. They're teaching the same shit that they were taught in the 1800s. They've never revised the curriculum.
Yeah, and it's a huge problem in every discipline of science. But it's also a legal logistical problem too, because the laws are always out of date. They're always written for the science as it was when they wrote the law. It doesn't adapt. And this is not I know this is kind of off topic, but
no, it's good.
We could easily write our laws so that they have deliverables. When have we ever written a law that says this law is meant to do X, Y, and Z and will expire if it does not meet some goal? That could easily be done. We could do basic programming with our laws. We could have laws that are adaptive, that have the principle of evolution built into them. If we pass a law that's meant to do something and then it doesn't do that, it should be automatically repealed. But in fact, not only is it not automatically repealed, laws are almost never repealed at all.
And almost impossible to get amended.
And almost impossible to get repealed. But we could write adaptive laws. We just don't. And it drives me crazy.
Dude, we're on the same plate, man.
But on the topic of this philosophical conversation, because I see the comment sections going crazy about it, is like plastic. If you take plastic and you break it down eventually into soil material, it is coming from the soil, and the process is an organic process of the worm breaking it down. So and it's expelling a organic material. So is it therefore organic? Well, the argument against is no, because you're starting with, you know, oil, which is coming out of the ground. It's like a mineral, which is what this other person is saying. So that's not really organic. But the counter argument to that, which I also see in the comment section, is plastic itself coming from oil. Oil once came from organic material. It came from carbon. It came from you know, algae. They say dinosaurs, but really carboniferous trees and stuff. So that's an interesting question. Like, where do we draw the line between organic and inorganic? It's like the artificial versus natural law, right? Like, if a human builds a log cabin, is that an artificial construct or is that natural? Because bees build hives, birds build nests. They're building structures. Are those structures artificial structures or are they natural structures? Is a skyscraper natural or artificial? Like, you got to draw the line somewhere. Where is it?
I think, personally, you'll love this one. So if you look at, you know, what's called horizontal soils, right? The buildup of soils, right, over time. The argument of, well, that's new soil versus the soil that's, you know, 200 feet down that has fossils in it. Is it new?
Where does it end? Where's the line, you know?
It's all the same shit recycled over and over and over again. So how is that new and that old? Right? It's the same freaking paradigm as what you're talking about, where because it was changed under human influence, it's now inorganic, when in reality, all the inputs were organic. So where, like you said, it's a bitch to draw the line, but I think that where the line should be is that as soon as you have taken it back to its original form, then it's considered organic, because you've processed it, you've taken the toxicity out of it.
Yeah.
You've taken the ability for it to affect humans and animals, you know, in hurting our digestive or having us break it down into other toxic forms before it gets back to the original organic form. But that's going to be an uphill battle, my friend, both with Omri as well. Omri probably not so much. Remember, Omri's kind of pay to play now.
Yeah.
But EPA is a bitch.
Yeah.
EPA is a bitch.
And they're very slow. They tend to go based on what is the current, you know, scientific literature saying, right?
Yep.
They're not going so much on, well, what is reasonable or logical, although they do that sometimes. So, you know, I just don't know. But I could argue this, right? If I get a piece of like OBM or OBS plywood and I leave it outside and I come back, I'm sure you've seen this happen with people's garden beds. You go back a couple of years later and it's sort of disintegrated and now it's part of the O horizon.
Yep.
Is that organic? I would say yeah, to some degree.
I mean, it's still got glues, still got residues.
Still got some residues, but the material itself, you know, or if another example, I'll give you a different one. If I put a piece of rebar out and that rebar rusts, it forms dendrites, turns into iron oxide over time, it disintegrates into red iron oxide powder, black iron oxide powder, and that becomes a part of the iron mineral component of the soil. Maybe it started as a piece of rebar or, you know, armor coating on a battleship, but now it's powder. Now it's soil.
Yep.
That's a tough one.
And I think that, you know, this is where a beneficial use of AI would be great, because you could start building algorithms that can help us better determine what state and compound is safe at, versus what point that it could potentially harm somebody. And I think that's going to be, if that's allowed to govern this the bureaucracies that control this kind of regulatory stuff, then that would work, and that would cause a lot of relief in really beneficial things, products, processes that could do so much good, but are stymied or pigeonholed because of that inability to make that determination, without letting money or lobby affect it, right?
Yes.
That at the end of the day, you know that the lobby and the money behind it is going to fight that tooth and nail as well. But
Yeah, and well, that's one of our biggest issues I think we're going to face is there will be parties opposed to this process of eliminating plastic by this means, because I don't know exactly how yet, but I'm sure this will make somebody somewhere look really bad, or it's going to make some company very upset.
oh god, yeah. It's called a shift, and the present in power organizations or groups don't want what we call a paradigm shift, because that means they're no longer in power. They're obsolete. You know, I love the story of the gentleman who was building wooden trunks that mounted on the back of your car.
Oh yeah, yeah.
Right. He had a business in Boston, had a business in Chicago, and a big business, I think it was San Francisco. He was killing it. And the car companies go, oh, wait a minute, why don't we just put one in our car?
Yeah, just make it part of the truck.
Damn, he was gone overnight, right? But he didn't have the power, the lobby, the money, the lawyers behind him to prevent that from happening. And that's been the business corporate model ever since: is kill, crush, and destroy your competition without thought or concern.
I mean, and there's the merit to competition, because it does sort the wheat from the chaff, and it takes, you know, businesses that are unnecessary, and or takes businesses that are stagnant and forces them to adapt, right? But like any good ecosystem, it needs to stay dynamic, and it can't stagnate. You can't have any one party become monopolistic. And that's what we've had now, is we've got this oligopoly. You know?
Yep. We call the responsible way to do things. They're demonized as, like, in medical, it's the free radical. Right?
Yeah.
Oh, the free radicals. Oh, you're going to get cancer. Free radicals. Free radicals are super beneficial in the regards they do keep shit in check, just like viruses. There are thousands of viruses to each one bacteria, and their virus's job is to say, if that bacteria gets out of control and starts out competing on a level that's not positive for evolution, they take it the fuck out.
Yeah.
Or it evolves, you know, through horizontal gene transfer or biosymbiosis. But that mechanism is driven by the virus, not by the bacteria itself.
Yes, and this is where the Soviets, they actually did something really interesting that I feel like we should have learned from this. It was a biomedical thing. So, by the way, I could go down a rabbit hole on Soviet technology, like unto itself. They came up with some really wacky stuff, because they didn't have a traditional competitive, you know, profit-driven economy. So they had a really weird, like, set of scientific things that they really delved into. But one of the things they delved into a lot was bacteriophages. They got really into using those rather than standard inoculations. So all our vaccines come from using the dead matter of different diseases so that our body can adapt to it, which is a great way to get, you know, smallpox or other things, to get those, immunities. Well, the Soviets went down a different path, which was to instead produce viral bacteriophages and train them to eat these bacteria, which is a really wild kind of, like, that's very, you know, different direction than we went in as our society. But it worked quite well. And as a consequence, it is much more difficult when you use a bacteriophage to eat, you know, bacteria or something, for you to then develop something like a super resistant bacteria.
Yep.
And now we're facing that problem where we have our antibiotics are increasingly becoming obsolete and ineffective. Yeah, because we're blasting them into our cattle. We're using them on fish tanks, right? Like there's tons of bacteria or bacterial supplements, antibiotics you can get for your fish tank.
Oh, I know. It's horrifying, dude.
It's really messed up.
Look at Roundup. It's
Roundup,
now five times strength, because the plants, the biology that support the rhizosphere have become resistant, and actually to a point where they've turned it into a food source.
In broccoli crops, this is going to sound kind of wild, but in broccoli crops. So I was at a conference the other day where I met like the premier broccoli expert in the East Coast. Almost all of the fungicides that we have used in the last 40 years have become ineffective. Nearly none of them work, and it's been happening at a increasing rate. So the second derivative is growing. The rate of change is getting faster, which is extraordinarily frightening because it means it's an exponential relationship. So the fungicides that are developed a year ago now or 2 years ago are ineffective today. And it's getting to the point where they're literally becoming ineffective like halfway through the season. So a single spore can now contact these broccoli and ruin half a crop or 1/3 of the crop because they've been using too many of these artificial fungicides. So,
and again, it goes back to phage.
Yep.
Compost extract is a phage. Get the competition in there. Don't wipe out the things that will keep them in check. You know, it's like nematodes, man. They go in there and they put down a nematicide on all the potatoes. Well, guess who comes back first? The fucking bad ones, because there were way more of them and they were way quicker to develop, or should I say, create a resistance or figure out a way to evolve, an evolution strategy to prevent that nematicide from killing them. And that's been repeated over and over and over again. And it's the same goddamn story.
It's now, because it's infinitely easier for those nematodes to become pathogenic. Eating something, being a parasite, evolves way more quickly and efficiently than the complex interplay that is symbiosis. It just takes more time to create symbiotes.
And again, with a phage, you can do it overnight. Well, maybe not overnight, but over a course of a season, you can get that soil health up so high that next year, if that pathogenic fungi or nematode comes out of cyst or spore, it's not going to have a chance. There's too much other competition to keep it at bay.
That's right. That's exactly right. And I mean, the other thing that's crazy is the irony too is that the nuking of the soil does create a profound opportunity to get symbiotes out there and to get them to spread. It's just you have to stop nuking the soil to pull that off. You have to stop for like a minute, just to let something grow.
Well, I'm telling you, I love conversations like this at this level, because whether we're solving any problems or just identifying them, it's still nice to say, here's the solutions, right? Products like yours, products like compost extracts, products like muncher juice, all of these things are going to take hold, change the narrative in the soil in a way, or in the plant in a way that, it will give you a greater benefit. And this is something else that we haven't gotten into, is nutrition. When you increase the bricks, you're increasing nutrition, right?
Yes, people.
Yep, you are actually also increasing pest resistance. This was highly debated years ago, and everyone was, oh well, bricks don't necessarily equal insects. Well, the latest information shows that the plant is actually reflecting a different color, a different hue, and that's what actually attracts the bugs. Others will say, no, it's a hormone, it's a smell or a pheromone. And
it can be all of the above,
Yeah, right. I tend to believe that based on the insect's eyes, it's probably more color related than it is, aura related than it is for it to be a chemical or chemosensitive. But either way, right? You, by default, you're making healthier soil, healthier plants. You're providing less food for the things that are going to potentially cause you harm. And therefore, with less of them, logarithmically over time, you're helping to support the larger ecology around you, because there's just not as much predation that could potentially hurt your plants, even if you aren't 100% biological, right? Even if you're just starting to dabble in it. Oh, I'm going to use a little bit of this. I'm going to use a little bit of that. You're still creating an environment where there are less predators around to attack you, and therefore you're going to be more successful. And that's going to speed up the process for you and your neighbor and your neighbor's neighbor, and on and on and on. I mean, we saw this when we were doing extracts in neighborhoods. Like, at the end of the cul-de-sac, you spray this house. Next thing you know, the houses around it aren't having the same problems that they were. And that just keeps spreading and spreading and spreading. And so, like what you're doing is affecting things a lot further downstream than you probably realize.
Yeah, and on that topic, I mean, there is a lot of biochemical sensing that we know happens. Like, for example, the jasmonic acids that a lot of plants release, the salicylic acids, they have aerosolized versions of those that come out of the plant's stomata. They're the methyl jasmonates, the methyl salicylates. Those are airborne, and they're compounds, they're hormones that the plant releases when they're stressed out or having a bad time. And so that communicates to the other plants, okay, we need to, the neighbors, okay, something's going on with one of my neighbors, I need to prepare for it. But I think the reverse is probably true as well, and we just don't really know yet. I bet there are probably aerosolized hormones that plants produce that are beneficial, that sort of, all right, hey, everybody, it's a good time to actually start working together to, put more roots down, or start producing more of these auxin-generating beneficial bacteria in your soil. We know that trees communicate by their roots, but I bet that there's an aerosolized component to it as well.
Yes.
Yeah.
Oh,
we know that pollinators definitely can see the color and the pubescence of plants and can make determinations from that.
Yep, when it's mature enough to harvest and when to come back.
Yes, and that comes from plant nutrition. So if you have a healthy plant, one that is producing more brick score, it's going to not only be able to, be healthier and be easier for people to eat in a way that is beneficial to their, body, but it's also going to potentially be able to communicate to other plants the conditions more efficiently so that they can respond more appropriately to that stimuli and do the right thing to then themselves grow more effectively.
Yep. Just like spreading the ecology. It's everybody's getting stronger, better, faster, and supporting each other.
Rising tide lifts all ships.
Amen. And something else that I really think you should do is reach out to some of these farmers that are having tremendous amount of success and tell them to send in samples to what's called Nestle Dublin, and it's in Dublin, Ohio. They do nutritional panels, and in the past we've demonstrated through biologicals that you can drastically increase that nutritional value. So they have a thing called energy. Well, energy equals the amount of energy that you have to use to consume it. So low energy is actually good, right? So there's some. It's not like common sense to read these tests. You have to like really be able to ask the right questions. And there's two different kinds. There's the basic chemistry, which tells you calcium, magnesium, and all the important things. But there's the other side of that test, which if you do that test, you can ask the other one, which is like, all right, water. What is the water content? Because you don't want water in your food. You can drink it. You want high density protein. But if you do side by side on NPK grown corn or beans and biologically grown corn or beans, it's night and day, dude. And this is the kind of thing that if enough people do this, they can go back to whoever they're selling to and say, hey, look, you want his corn or his beans or his lettuce, or you want mine, right? Here's the information, because we need information to make intelligent decisions.
Yeah.
And we are purposefully not given that information, so that we typically just drive to, oh, well, that costs less, so therefore I can afford to buy more, right? Not, oh, it costs more because I'm going to have to eat less of it, right?
It is a great tragedy. I mean, I think I talked about this last time. The brick score or the nutrition quality of oranges has declined in Florida by like 7 times since the 1960s. Mm-hmm. It's been a horrendous drop in nutritive quality. We are fighting a war right now against poor quality food and poor quality soil. And for the most part, the intelligence aspect of that war is just fog. We have a fog of war,
Yeah.
people don't realize the value of organic. At the same time, the value of organic is very difficult to identify just from growth because you literally can't see it for the most part in a lot of cases. And then finally, in the cost aspect of it, when you get the product at the end of the day, it's more expensive when it's organic, you know?
And
The box, yeah.
it shouldn't be, because there's less inputs. There's
Yeah.
less labor. There's so much more to it. But that, here again, you know, the powers that be that control the system, the monetary system, force the organic farmers to jump through crazy fucking hoops to get certified to a point where then they're able to enter the market. But sure, you know, at the end of the day, it's you know, it's not just the expense and the fact that the inputs are less. It's the fact that you're competing against these giant factory farms that can produce so much that it goes back to the numbers. You know, it's like if you can produce 10,000, you can sell it for a penny. If you're only producing 100, hey, you got to get a buck, right?
Yeah. Well, and that's where we're, I think, trying to make our biggest dent, is that ultimately, yeah, we've got great innovations with this plastic digestion stuff. We've got great innovations with the shelf stability. But where we can really make a difference is our fertilizer, our worm casting tea, is capable of being plugged into an industrial farm. And that's where we have a big advantage, because that's who we're selling to right now. 90% of my business today is major farms. It's the big industrial farms, 1,000-acre plus guys. And it's there where the war has to be won, because that's where most of America's topsoil is. You know, that's where most of our food comes from.
Yeah, most of the produce comes from there.
Exactly. So that's where we're fighting today, and I think we're about to go over time, but I wanted to point that out. I mean, I think we're making a big difference there, and I really appreciate you having me on the show to talk about this stuff and to discuss such an important topic.
Agreed. And next time you come back, we got to get down Russian technology, because like they have so many other things that they are so far ahead of us. Like just humic acid, right? Fulvic acid. Like we don't even acknowledge fulvic acid as existence here in California.
No. And then there's there are things we are definitely ahead of them in by a long shot. Like Russian rocketry, friggin' sucks compared to ours. We make very good rockets, but they have some very creative and unique things. But yeah.
Sam, did you have to bounce at an hour and a half? Because typically we usually ask questions now.
I can do questions for like 10 minutes, but then I gotta go.
All right, sounds good. Let's try to bust through these questions.
Well, we've only got two. Would Sam's process work with other organisms? Crickets have been studied for eating microplastics, which they poop out to non-plastics.
Nanoplastics. So they reduce. It's probably because they crunch it up. You know, they're redistributing. They're not consuming.
So the process would work, but it's on the other end. So we're starting with the plastic like this, and then we're turning this into an oil, and then the oil is getting fed to bacteria who are actually breaking the nanoplastic, the oligomer, down into biodegradable material. Yes, mealworms as well. Superworms, mealworms, black soldier fly larvae. I've actually tested all of those organisms. But the big problem with all of those guys is that they leave nanoplastics behind. And if you're turning microplastics to nanoplastics, you're just kind of spinning your wheels, you know. What the end goal is to have no nanoplastics, no oligomers, no, wacky PFAS, other compounds like that. We don't want any of that. We just want solid, entirely biodegradable organic material. And that's the benefit of this process. Crickets could be used to eat the biomass that results from the bacteria if you wanted to make crickets. So could mealworms, so could superworms, so could black soldier fly larvae, and perhaps even other organisms as well. The biomass that results from the bacteria digesting the oils and the nanoplastics, that has value unto itself. But right now, it seems like the best way to do it, based on the math we've done, is to turn it into worm castings. It's a good question. Very good question.
Okay, her next one is, I heard that an acre of land, one needs 2 gallons of worm castings. As a small scale farmer, I have made that much. Do you feed your worms anything in particular and add amendments?
It's a good question. So it depends on the worm castings. I mean, I think 2 gallons an acre is a fairly good rule of thumb. We do actually 1 quart to 1 gallon an acre. So we're definitely on the lower end. I think that's because ours is more concentrated. We do add other things to it. We add chitin, which is the shell of lobster and crab. That's a boost. It actually acts as a flocculant, which is beneficial for the casting stability. But it also has some other benefits because it's a kind of immune activator for plants. So that probably increases some of the efficiency of it. We also just optimize the solubility of the casting. So a lot of people will take castings and then they'll mix them in with water, but they don't know the optimal ratio. We have kind of optimized the pressure of the water and the amount of time it has to sit.
Do you use any surfactant?
We don't use any surfactants in the actual process. We do use surfactants in the cleaning beforehand. Though we did look into that, but it hasn't been necessary yet. But it could be useful. Surfactants have a lot of benefits in agriculture,
especially if you're foliar.
Yes, especially if you're foliar. We've tried nanocellulose as a stickying agent. It's not quite a surfactant, but it does make things stick better, and that has proven beneficial. So we may go down that road in the future.
Got you. Well, I'm glad you looked into all of this shit and you continue to, because I think that's the key to getting to that point where you can say, okay, we got it figured out, go, right? And instead of burning a lot of money, you still have a small R&D department, but you're not spending as much as you need to continue to develop, and you're spending more in getting that product out there. So.
And it can be surprisingly cheap to test out these hypotheses. You just make a little extra batch here and there. You send it to some farms. You collect some data. It doesn't have to be thousands and thousands of dollars. It can be relatively cheap. In fact, you can even get paid to do it if you have farmers excited about enough. You say, hey, I'll give you this for a discount. It's slightly experimental, but if you like the stuff as it is, give this a shot. So I think R&D can be done by small businesses in the fertilizer world pretty easily. I think a lot of people don't do it, more so because they just don't want to.
Yeah, or they're still so focused on the money. Well, listen, Sam, I really appreciate your time, my friend. Ken, we'll stay on and do the drawing after he bounces. Yeah, please come back in another 6 months. Let us know where you're at, what's going on, because you're definitely fast track on a lot of this stuff, and it's super interesting. And I know the audience loves to hear about these kinds of things and the potential for them to be released in their neighborhood or being able to purchase the stuff. So
good
work, man.
I hopefully next time I call you, I'll be calling you from a nicer place.
I kind of like your place, dude.
It's got character, dude. It's got spunk,
Yeah, it's got character.
I gotta give you a tour of this sometime. If you're ever on the East Coast, you come by and I'll show it to you.
All right. Well, maybe I'll actually send a buddy of mine over there. He's down in
please do.
He's in Florida. I forget where he is now, but I'll have him watch this podcast for sure.
All right. Well, thank you, gentlemen, and thank you everybody for your time. If you're interested in learning more, it was on the screen earlier, but our website is WriggleBrew.com. That's us, WriggleBrew.com. And you can also find us on all the social medias and on Amazon too. So. All right.
Cool.
Thanks,
guys.
All
right, take care of yourself, my friend.
Wriggle on.
You bet.
Yeah, wiggle on.
Okay, so let's anybody that hasn't figured out that we are running the contest again today, you have to put in hashtag biology to have your chance to win. And it's hashtag biology, and we'll run it in a few minutes here. But that was an amazing show with a lot of fantastic knowledge, Leighton.
Yeah, no, that kid's smart, man. He's got it together. And he's not limited either. I mean, for him to start talking about bacterial phages and understanding, and that was something I wanted to go into deeper so people can understand it. But it is complicated. but it's more of like getting things to work together, kind of like what we're doing in the soil, right? Getting everything to work together, not through killing, but through stimulating. And there's a huge difference with that. Now, you don't have as much control. And so the potential for things to go sideways are there, especially if the person is so compromised that they can't take the potential from this bacteria or community. They can't protect themselves against it. And that's where, it gets a little bit dicey, but this is where you go low and slow, very little bit, try it, see what happens to the person. Whereas now it's just, pop that antibiotic and you're good, right? Or go on this course of antibiotics and you're good. But at the end of the day, we're seeing what's happening with the, Pandora's box being open to the point where everything is resistant now because it's so deep into our society, our food, our water, that it's everything is resistant now. And sooner or later, one of these superbugs is going to get free that was around, friggin' millions of years ago that did do a job that was necessary, but ended up getting frozen in a tundra. And sooner or later, a bird's going to fly by and, eat a worm that was next to it. And who knows what catastrophes could happen. But that's kind of the way nature works. It's just we humans tend to think, oh, we're in control of all of this. We got to control it. Well, nature's going to push back sooner or later, and it's not going to be pretty for those that are around when it happens.
Well, people have to figure out that we're not in control of anything, that nature is actually in control. But I liked him pointing out, how the one spray is, isn't even, lasting for a complete crop before the biology is able to go, no, that's not going to be effective anymore. Like we've had Dr. James White on several times talking about how fast things change biologically, and we're just seeing it more and more and more. And that was a perfect example of that.
Yeah, once you start using chemistry to fight biology, it's a slippery slope. It's a slippery slope because they're going to get used to whatever you do.
Well, and in some ways for us as human beings, it's a damn good thing that they are able to do that and work that fast, because the methodology that's out there that's really damaging us physically and our soils physically, Mother Nature has to be able to take that and turn it back around, for us to be able to survive. So I'm glad that the biology can change, second by second by second to compensate for what's being done on our planet.
So, there was one other question that Farmer Cheryl, and I love you, Farmer Cheryl. You really do ask great questions. Isn't biosolids used to grow a lot of the citrus, Florida citrus? Well, I don't know, but biosolids have been banned in a lot of states because of the volume of these, forever chemicals, hormones, heavy metals, because they all precipitate out under that highly biological concentration that's occurring in waste treatment facilities, specifically water waste treatments. So you're basically just making everything super concentrated and in the biosolids. And then when you take those biosolids out to a field, I mean, there's a couple of cases, some major lawsuits up in Maine where biosolids were used on organic farms and now they can't grow anything. They're not even allowed to grow any vegetables. So they lost their farm as a result of these biosolids. So I think that, in order to use a biosolid, you would have to do some serious biological remediation, like phyto remediation or biological remediation, where you can precipitate these heavy metals out and then collect them, where you can break these hormones down. And I'm not even talking about pharmaceuticals. The level of pharmaceuticals that are getting through the wastewater treatment process is staggering. Because again, we as a species, Americans, are the worst. We're so over medicated. And our bodies can only use a fraction of that medicine, because this gets into subatomic particles. But if the electron isn't in the right rotation and in the right level in the magnetic field, your body can't consume it. It won't take it up. It just excretes it, which is, again, why we have to use such high levels of these medicines, is because they know only 1 or 2, maybe 3% of the actual compound will be bioavailable for human consumption. Anyway.
And you're just digging away. Somebody wants you, man. Somebody wants you bad.
It's Monday. Anyway, well, let's go ahead and do the contest and see what goes on. And while you're spinning the wheel, I've been in contact with Perky. He's set up. He's hopefully going to be online and live in another 2 to 3 weeks, and he can't wait to come back on the show. Congratulations. Sour tips? How do you pronounce that?
I would think sore tips. The sore tips, you're going to have to email me at itsallaboutthebiology@gmail.com, and I will send you over to Perky, who we were just talking about, and he will set you up with the chorus. If anyone else wants to purchase the chorus, the link is actually in the description, that you can order Leighton's chorus online. So it's really easy, guys, to enter this contest. We're trying to do this every week so that this chorus gets out, because it's knowledge that is really necessary. And I'm looking forward to having Perky back on. We don't have a guest set up for next week. We'll see what we can do. We've got Dirt right after that. He's going to be coming back on, showing us how his facility, his gardens, his composting, etc., is going after he was on this spring. But there's always great information on our channel, guys. Wednesday, Andy and I can't remember exactly what we're talking about, but we're going through his book, so you're going to want to check that out and see what's happening on Wednesday. Leighton, do you have anything else you'd like to say?
No, I think we're good for now. There it goes again. So it's clearly I've got to bounce, but appreciate you, Ken, for all the hard work that you do behind the scenes to make this happen every week. And send my love to Silly, and peace out to the audience. Have Merry Christmas, Happy New Year, and hope that you're in a great place this holiday season.
Okay, guys, take care.